All right. We're going to do the best we can with this here review. I hope you guys are having a great day. Make sure you listen up and pay attention because the test is tomorrow. Okay? The first one says, which graph best represents the system of equations and its solutions? Notice we're looking at a graph, so that means we're going to want to plug this into y equals, right? And if we want to plug this into y equals right here, that means the equation needs to be in y equals. So when we look right here, you have to ask yourself, is this equation in y equals? Right? And the answer is no. It's not even in standard form. Don't forget standard form either. Standard form is ax plus by equals c, where a, b, and c just represent numbers. So the number part needs to be on the right. The term with the x and the y needs to be on the left. And as we can see here, the 6 is on the right side of the equal sign, but this y is on the right as well. It needs to be on the left. So what we're going to do here is take this equation and we're going to put it in standard form by taking this y and putting it over here. Don't forget, this is the same kind of situation like we're solving, right? There's the door, x is in the house, and y wants to be in the house. So we got to do the opposite of minus y by adding y to each side so that it cancels on the right. And what we end up being left with is 2x plus y equals 6. And that's a little bunched up there, but I wanted to make sure we understand that it's 2x plus y equals 6. Now we have standard form, and we're able to put this in y equals like we know how. How do we do that? Remember the open parentheses right here in front of the 6, and we're subtracting 2x from each side. Close parentheses divided by our coefficient of the y is 1. So remember, as we write on the right, I always tell you to erase it from the left side so you know where we're at in the process. And yes, now we're in y equals form, so this can go in the calculator. The second one is already in standard form, so all you have to do is put your parentheses in front of the 28. We're subtracting 5x from each side. Now that we've subtracted it, you can kind of erase it over here. And then we divide by what's left, which is the negative 4. So we erase it from here. And now we know that we're in this y equals format that we want. So from here, you just take your calculator, right? Remember, this is the y1 right here. That's what we're going to put in y1. And here, we're going to put it in y2. So y1 is open parentheses. All right, trying to brighten that up a bit. Open parentheses, 6 minus 2x, close parentheses, divided by 1. And in y2, we plug in 28 minus 5x, close parentheses, divided by negative 4. Press graph. It looks like the intersection is here in like the 4th quadrant. And the only one that has a solution in the 4th quadrant is B, which means B is our solution. Okay? All right, number 2. It says, when the number of people in... All right, so first off, it says, which situation causes causation? Remember, causation just is like a cause and effect relationship. One causes the other to happen. So it's a cause and effect relationship. When the number of people in a bus increases, the number of animals in a zoo also increases. I don't think one has to do with the other, so we know that's not it. When the number of hours worked each week by an hourly employee decreases, the amount of money earned by the employee also decreases. Yeah, I think that makes sense. You don't work, you don't get paid. So this definitely sounds like a cause and effect relationship. But let's look at the other ones. When the amount of discount for a sale increases, the number of items sold during the sale decreases. Not necessarily true. When the amount of the discount increases, the number of items sold decreases. No, I would think it would increase. So that's not it. When the number of bike trails in a city decreases, the amount of rainfall in the city increases. No, one does not have to do with the other. The answer is B. All right, on this test is not just systems causation, but also you may have to find your line of best fit or linear regression model and answer some deeper questions. So this one is talking about a company advertises on a website. A worker tracked the number of visits to the website and the number of clicks on the advertisement. The table shows the data for several days. A linear function can be used to model the data. So we have this data, right? And we know that this is going to form a linear function. We can determine what that linear function is going to be by plugging it into the calculator. So it says, based on the table, what is the best prediction of the number of clicks? Remember, number of clicks here is Y. So we're going to just make ourselves a note, number of clicks, Y. It says, what is the best prediction of the number of clicks on the advertisement? So we want Y. If 1,500 or 1,500 people visit the website. Well, the number of visits on the website is X. So what we want to do here, mark it, X. Okay, that's X. That's X. So we want Y when X is 1,500. But before we can do any of that, we need to find the equation. So let's take our calculator and we want to go to, let's slide this over. All right, we want to go to stat, enter, and we're going to put this left side into our L1. So maybe go ahead and make yourself a note. This is going into L1. This is going into L2. So L1. And then in L2 is going to be our Y's. So 14, 38, 30, 53, 21, 60, 32, 63. All right, from here, we need to find our equation. So press stat again, go over to calc, and we want to calculate the linear regression. So we're going to click 4 and press enter. Okay, and here's our equation. We're given Y equals AX, so our A is 0.05, I'm going to say 2X plus 5.539. Okay, now it said it wants Y when X is 1,500. So this is actually going to require a little bit of substitution. What is Y given 0.052 and then plug in 1,500? Now you could do this a couple of ways. You could just plug this portion into the calculator and press enter to see what happens. Or you could go to Y equals, erase what's there and plug this in. 0.052x and then plus 5.539 and press second graph to look at what's happening. But you got to go all the way down to 1,500. How do you do that quickly? You can change this table set. Where it says here in the blue table set, you can press second window. And instead of telling it to start at 0, you could tell it to start at 1,500. And then press second table again, and you'll start at 1,500. you see that this is 83.539, which is closest to H. If that's too much, you're not going to remember it, fine. Don't do that. Just plug this in. 0.052 parentheses 1500 plus 5.539. Enter. And you're still going to get that 83.539, right? So that's what we're going to write here. 83.539, which is H. Okay, that's H. All right, let's keep going. Let's keep going. So if we look here, it says which graph best represents the system of equations and its solutions. We're looking for the graph. Remember, graphs have to be in y equals. Ask yourself, is this equation in y equals? And is the next equation in y equals? We know that answer is no. Then you have to ask yourself, is it in standard form? Don't forget, standard form is ax plus by equals c. It's not in that form, but we can put it in that form, and we've been practicing it. If you don't know how to do this, you're not prepared for the test tomorrow, so make sure that you are. We do that by putting our parentheses in front of the negative 16, and we got to subtract 8x from each side. As you subtract on the right, erase it from the left. Then we're left with the negative 4y, so we divide by negative 4. Now that we put the negative 4 right here on the right, erase it here. And now notice we're only left with y, which means it's in y equals form. Go ahead and put this into your y1 in your calculator. Okay, so negative 16 minus 8x, close parentheses, divided by negative 4. Okay, now let's do the second one. Put that in y equals form. So open parentheses, minus 3x, close parentheses, divided by 15. Now that we put it on the right, erase it from the left, we're left within that y equals format that we want. And put this in your y2. So we have negative 6 minus 3x, close parentheses, divided by 15. Press your graph. Notice how that intersection is happening about at negative 2 on the x-axis. The only answer choice that does that is B. So that's our answer. Okay. Number 5 says which situation shows causation? The length of a rectangle affects the width of the rectangle. No. The amount of time cell phone is used affects the charge of its battery. That's definitely true. That's the cause and effect relationship, and the other two aren't it. All right, now let's come here to number 6. It says, which graph best represents the system of equations that has no solution? Remember, no solution is when we have parallel lines because it doesn't cross, right? So no intersection, no solution. So we got to come here to each answer choice and see which one has parallel lines. We know it's not A or C. B might be it. D might be it. When we look here, see how these arrows are going? That means it will continue even past this window. If it were to continue, would they intersect? The answer here is yes, so it's not it. But look here. They clearly are going in two directions, never have any intentions of intersecting. The answer is D. All right, come here to number 7. It says the table shows the height and lengths of several rectangles. What does the correlation coefficient, that's key word, correlation coefficient, remember that's R, right? R. What does that show? It says for the data indicate about the strength of the linear association between the height and length of these rectangles. All right, so remember with correlation coefficient, it's been a minute, so I'm going to try to remind you that on the left end, there's -1. On the right end, there's 1. And in the middle, there's 0. Remember, -1 means this is like perfect. This is all the points on the line. This is a strong negative correlation. Here at 1, this is a strong positive correlation. And 0 means there's no correlation. This is also in your notes, right? When it's strong negative, it's all in a line. Strong positive, all in a line. No correlation, you can't tell whether it's positive, negative, what, because it's just a big old scatter plot, right? And the closer it is to -1, the stronger it is. The closer it is to 1, the stronger it is. But the difference is one's negative, one's positive. So when we look here, right, this is like our line of best fit, linear regression. But right now, when I plug this in to stat, I'm going to clear this out. What you're going to get, like this is going to go into, this is our X, this is our Y. So this goes in L1 and this goes in L2. And so what's happening is we're going to put the height into our L1. Sorry guys, trying to put this all together. All right, so 21, 34, 10, 92, 54, 24, 10, 35, 42, 66. In L2, this is 21, 25, 32, 12, 16, 45, 40, 23, 45, 35, 21, 14. All right, and if we go and try to find an equation for this, right? So stat calc 4. We have an equation, but it tells us nothing about the correlation coefficient. This is where we have to go and turn the diagnostic on. So make yourself a note that you need to turn the diagnostic on. How do you do it? By pressing second 0, okay, in the calculator. So second 0, scroll down, until you see diagnostic on. Enter, and then press enter again so that it says done. Now if we go in and press stat calc 4, now it gives us an R. It says R equals 0.1554. Now, which one is that closest to? Is that on the positive end, negative end? And then is it closest to 0 or 1 or -1? Well, when we look at this here, 0.15 is close to 0, but on the positive end. So this is said, since it's 0.15 or 16, we'll say 155, that's close to 0, but it's positive. So this is said to be a weak positive. So we know the negatives aren't it. It's a weak positive. Okay? It's a weak positive. All right, what about number 8? It says, which graph can be used to find the solution to the system of the equations below? Graph, that means y equals, right? So remember these, you got to determine, is it in y equals format? This one isn't, but it is in standard form, you know, ax plus by equals c, right? It is in that form. This one, it's not in either format, but I think we can easily put it in y equals because all that's attached to the y is the -3. So let's deal with the first one first. We would put our parentheses here, open parentheses, subtract 2x from each side, close parentheses, divided by, the coefficient is 1. Make sure you erase that from over here because now we're in our y equals format. This will go into our y1. And then here, all you have to do is put parentheses here and divide by -3. And that cancels here, and we're left with just y equals. So now we can put this in y2. So let's clear out what's here. And we plug in -4 minus 2x, close parentheses, divided by 1. I'm sorry, I put that in y2. It's okay. We're going to put in y1, then y2, so that we don't have to erase. 2x plus 12, close parentheses, divided by -3. Press graph. And when I look and observe F, H, all that, the only one that fits is F. All right, F is the one that fits. All right, now number 9 says which one does not show causation? When the student population at the school increases, the number of teachers at a school increases. No, that's causation. So that's not going to be our answer. When the amount of sugar of a quart of apple juice is reduced, there are fewer calories in each serving. No, that's causation. When there are more workers on a project, the project is completed in less time. That's causation. When there is more protein in an athlete's diet, the athlete scores more points in a game. No, that's not causation. So that's our answer. That's what we're looking for. Number 10 here. If the graph of the second equation, the line graphed on the grid represents the first of 2 equations in a system. So this is our y1, basically. Think of it that way. It says if the graph of the second equation in the system passes through the point -1220, and so -1220 and 412, which statement is true? Well, since it passes through this right here, and I don't really have a straight edge, so I'm going to use this little paper here. Be something like that. All right. Says which statement is true. These look like parallel lines, right? And if they don't intersect, they don't have a solution, which means A and B are out of the running. It says the system has no solution. Yes, that's true. It's not infinitely many because infinitely many would only be one line, right? These would have an intersection. Number 11, what is the solution for this system? Remember, open parentheses, minus 2x, close parentheses, divided by 1. Here, same thing because it's in standard form. Minus x, close parentheses, divided by -2. So just put it in your calculator to see what's up. All right. So this becomes 40 minus 2x, close parentheses, divided by 1. This one, -20 minus x, close parentheses, divided by -2. Second, no, not second. Just press graph to see what's happening. All right, I don't see much, so I'm going to zoom out to make sure there's nothing else going on. And what I did was I just pressed zoom and then clicked on out. All right, I'm glad I did because there is something going on. It just wasn't in the proper window. So now we can press second, trace, 5, enter, 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 right? So here we zoomed, right? We pressed zoom and 3, enter. That was what we had to do here. And then we press second, trace, 5, and enter 3 times. Before we did that, we pressed graph to see what we see. Because sometimes you got to press graph so you can even see if there's a problem. Okay. So here we did that. Second, trace, 5, enter, enter, enter. And it said the intersection was at 1216. Which answer is that? It's A.